What's up, everybody? It's Coach Sharf. Welcome back to my Algebra 2 videos. Today, we are looking at logarithms. We have an introduction to logarithms. We're going to talk about what a logarithm is and look at our first rule, our first property of logarithms, the change in base formula. So let's get started. So as I'm popping this up, there's only a few examples I'm going to go through. Mostly what I'm going to do is in a real-time setting, I'm going to have about a 10-second pause with each slide, which will actually let you pause the video to write down the slide. And then you can hit play while I talk about the slide real quick and move on. So hopefully it'll cut down the length on this video a little bit. So introduction to logarithms. So if you're picking back up from the last set of notes, the real world exponential function notes, you can kind of make a separate heading in the middle of that note page and just continue it if you're keeping all of your Unit 5 notes together. If you're starting a new page of notes, you can just make this the header at the top. All right. So let me move my head so I'm not blocking that word. Again, I will pause for about 10 seconds of real time. You can pause the screen to write this whole thing down, and then I will explain it. All right, it says a logarithm is the opposite function of an exponential function. Well, what we discussed a little bit ago was the square and the square root function. That was, the last unit we did before we did Unit 5. I don't need that. So we're saying it's different from the square root, cube relationship. All right, so, again, if we have x squared equals 36. All I know I have to do is to square root both sides. But so if I do that, I was getting ahead of myself. X equals 6. I have x cubed equals 27. I can cube root both sides. Cube root both sides. X would be 3. So we got that. So this is for when I don't know what my exponent is. So for an example, 2 to the x power equals 8. Okay, we're going to use this example a few times. Again, a lot of y'all might be saying off the top of your head, 2 to what power equals 8? X is 3, 2 cubed is 8. Okay, hopefully we know that. But what if I got 2 to the x equals 21? Well, I know 2 to the 4th power is 16, 2 to the 5th power is 32. So x isn't going to be an even number. I can't multiply 2 times 2 times 2 times 2 a certain amount of times and get 21. So x is going to be some number with some kind of decimal. The number is actually going to be between 4 and 5. We'll use logarithms to figure that out. So logs are used to find an exact value for an unknown exponent in an exponential function, what I was just saying. So logs in logarithmic form and the exponential form like this have a relationship, which we'll explore here in a second. So once we understand that relationship, logs may also be solved on their own when just given a logarithm and trying to find a missing variable, not an exponential function. And they also have their own special properties. Again, we'll talk about one in this set of notes, and we'll talk about some more in the next video. All right. Next slide. Again, I'll pause for about 10 seconds real time, let y'all write this down, and then I'll talk about it. All right, so obviously I clipped this from the textbook. I used the snipping tool to snip it out of the PDF. Definition of a logarithm: let b and y be positive real numbers with b not being equal to 1. I'll briefly talk about y on the next slide. The logarithm of y with base b is denoted by log by and is defined as log by of x. And it says if and only if, but we're converting back and forth between these forms. So it says if and only if, but this is operating under the assumption b to the x power equals y. okay? So, 2 to the 4th power equals 16. It has to be that, all right? Can't be 2 to the 4th power equals 5,000 because we know that's incorrect. So that's the operation. That's the assumption we're operating under. The expression log by is read as log base b of y. Because again, this b is your base like it is for your exponential function. So the other thing you have to know is you have to be careful how to write it. This b is a subscript, so it has to be written under the log, and then whatever your y is written on the same level. So log base 2 of 16, right there, that's correct. You'll want to write b on the same level as log, and then y looks like an exponent. So log of 2 to the 16th power, okay? Log base 2 of 16 is equal to 4. Log of 2 to the 16th power, let me get that out real quick. 2 to the 16th power is 65,536. So log of 65,536 is 4.816479931. So just coincidentally, they're, log base 2 of 16 is 4. Log of 2 to the 16th power is like 4.8. So, they're not crazy far apart in terms of whatever answer you would get, but it's still incorrect. Okay. If I asked you to evaluate this on a test, 4 would be an answer. And then if you accidentally did it like that, 4.81 would probably be an answer. And if you chose 4.81, you'd be wrong. So be careful how you write your logs. All right, another page of examples here. So we're just converting back and forth between log form and exponential form. Again, I'll pause for about 10 seconds of real time, and then I will explain these. All right, so we got 4 examples. On the left, we're converting from log form to exponential form. On the right, exponential form to log form. And to me, this is a similar idea. I don't want to keep clicking that when I'm inactive. This is a similar idea of when we were converting between radicals and rational exponents. So we had the n power of a to the m, the n root, excuse me, of a to the m power. The same thing as a to the m over n power. It's kind of the same idea. A, m, and n don't change. You just, when you change it back and forth between the forms, that's how you write it. So log base 2 of 16 is equal to 4. We just had that on the last one. In exponential form, again, we flip it. B is 2, that's our base. X is our exponent, which is 4. Y is our solution, which is over here. So 2 to the 4th equals 16, all right? So again, what the idea is we're really asking this. Okay, I'm going to replace this temporarily with an x. Hopefully you wrote it down, so you don't necessarily have to replace this with an x. Okay, 2 to the x power equals 16. You could be missing different ones of these, but for the most part, this is what you're going to have. This, and trying to figure out what's equal to. So the question you're really asking is 2 to what power equals 16, okay? 2 to what power equals 16? That's all the logarithms asking. 2 to what power over here is equal to 16? That's all it's asking, okay? It's based, again, just 2 to what power equals 16. Just took this and rewrote it. Log base 2 of 16 equals x. 2 to the x power equals 16. It's just rewritten. It's asking the same question. Logarithm's not a scary thing, guys, as long as you understand it. That's all it's asking. 2 to what power equals 16, okay? Here we'll skip B. Again, that's about having a 0 exponent, anything to the 0 power is 1. But even look here. 12 to what power is 12? All right, 12 to what power is 12? Well, anything to the first power is itself. So 12 to the first power is 12. 12 to the first power is 12. That's all that one's asking, okay? So we got some similar things over here. And again, with some of these exponents, we start to get into the properties of exponents. Again, I'm not really concerned about, we'll look at C because C comes back to this up here in the left-hand corner. I'm not concerned about you knowing right now 8 to the 2/3 power equals 4, but I do want you to be able to, if I give you this, to turn it into a logarithmic function. All right. Okay, next slide. Oh, whoa, way ahead. Sorry. All right, the common log and the natural log, right? Yeah, common log and the natural log. So if you have a log with any old base, 3, 5, 8, 100, whatever, it's just a log, okay? We have log base 10, that's what we call our common logarithm, because base 10 is what our entire number system is based on, right? So every digit that we go up, right? Every digit that we go up. So singles digit, tens digit, hundreds digit, thousands digit, 10,000s digit, 100,000s digit, millions digit. We're multiplying by 10 to go up each digit, right? So our number system operates in base 10. That's why it's called the common log. So if you ever see a reference to a common log, it is log with base 10 or simply log. So log base 10 of x is equal to log of x. If you say a log with no base, we assume it's base 10. All right, so what I have in blue over here is this. And you can go back to the beginning of this page. I realize I kind of talked through it without y'all writing. Y'all can go back in the video and pause it real quick and write what was already on the screen, but I'm about to add a little bit to it. So maybe I'll pause for a little bit once I have everything written and make sure y'all got it, and then we'll move on. So log base 10 of x equals y, log of x equals y. Those are both asking this, 10 to the y power equals x. 10 to what power equals x? That's all it's asking, okay? So if we're working with log of 100, we're working with log of 100. Again, we're assuming base 10 here. If you want to put a 10 down there, that's fine, but you need to, again, you need to know on a test when you see that it is base 10. So, if you can get more comfortable operating without writing the 10 down there, just knowing that it's supposed to be base 10, that's all right. So log of 100, log base 10 of 100, same thing. So I don't know if this will make it any better when I've tried to show the calculator in the past. Let me stop sharing for a second, and it'll pull up me blowing up pretty big. All right. So let's look at our calculator. All right. Let's look at our calculator. Scientific calculator. All right. Again, if you look under the second button, there's log and ln. Our calculator always assumes log base 10. That's what it's programmed to do. You can't change the base. All right, so in that instance, when I have log of 100, let me actually show it on the screen instead of typing it and then showing you. All right, when I have log of 100, I'm going to hit log of 100. All right, and we'll close parentheses. All right, so log of 100. All right, so that's how I type it in if I'm trying to evaluate it, and I hit equals. Before I do that, let's go back real quick. It would help if I would share it instead of just flipping to it. Let's go back to it. All right. So again, if we're assuming base 10 down here, again, let's think about what this is asking. It's asking 10 to what power equals 100? 10 times 10 times 10 times 10 times 10, so on, so on, so on. How many times do I have to multiply 10 to get 100? Hopefully, you know the answer is 2. All right. So let's stop sharing. Let's pull the calculator back up. And when I hit equals, I should get 2. There we go. All right. If you're using, again, your phone calculator, I'll pull up the calculator here. Your phone calculator, you got to do it a little different. When you're calculating a log here, okay, I'm going to turn it sideways. You have to type in 100, okay, 100. I got it in. All right, if y'all could see it, next to, it's a little blurry, I realize that, but next to the 4, all right, next to 4 is log base 10. The natural log, which we'll talk about in a second, is next to that. So I'm going to hit log base 10. And it gives me 2. So there we go for that. All right. So if you're evaluating a common log, you just punch in your calculator quick and easy. You can also do the same with a natural log. A natural logarithm is a logarithm with base e. There's that e, that natural number, that Euler number we just got done talking about with the continuous compounding, right? It can be denoted by log base e, but is usually denoted by ln. Okay, it's usually denoted by ln. So that's that ln button on your calculator. So log base e of x equals y, ln of x equals y. So again, two things I want to say here are, even though technically this isn't correct, if you see ln of whatever, if you want to put a little e down there to remember that that's your base, go for it. Technically, it's not correct, but again, this is mostly about you getting the right answer. And if we're dealing with these, if that's what's going to take, you put a little e down there, that's okay. So whether I have the e or not, again, both of these are asking the same thing. E to what power equals x? E to what power equals x? If we remember, e was equal to about 2.718. Again, it's kind of like pi. It's a number, it's a decimal, it goes forever, but we rounded this. So again, what you're saying is 2.78 to some power equals x. So, if I had an ln of 12, we'd have e 2.718 to what power equals 12. What I'm trying to make here is our x is probably going to be a decimal. But even over here, if I had anything other than log in a multiple of 10, so log of 1, log of 10, log of 100, log of 1,000, log of 10,000. Keep going, keep going, keep going. For the common log, if it's not a multiple of 10, it would have been a decimal as well. Okay. So we know this was going to be a decimal. So don't get freaked out just because it's a decimal. All right. So ln of 12 equals. All right, we're going to do the natural log of 12. So again, let's pull it up. We're going to hit natural log. Our hit it as I was accidentally turning around, but it's the ln button right there underneath. Oh, using the wrong finger. I was using that finger. That's the ln button right there underneath the log. Okay, so ln of 12 equals 2.48490665. So we'll round it to 2.48. All right. Again, I'll show you on the iPhone calculator as well, just in case you want to see it. Well, how about this? I'm fine with y'all doing 2.48, but I'm going to do 4 decimal spots just to check it here. And I'm going to talk about checks a little more in a second. Okay. So let's look at the iPhone calculator real quick. Let's stop sharing so I can pull it up. All right, calculator. Got 12 in. Again, you're going to hit that ln button. It's next to log base 10. Right there, got the same thing, 2.4849. All right, so, if you wanted to check it to be sure, okay, again, really what you're saying at this point is, look, this was my y, this was my x. So, even kind of comparing it up here, we're saying e to the 2.4849 exponent is equal to 12. All right. So we talked about with the compound, the continuous compounding, how to find e. So I'll do it again. I'm just going to show it on here real quick. Again, this is just a check, guys, but here you would hit second ln and it would pop up. There's an actual separate button on the iPhone calculator. So e to the 2.4849 power, it equals 11.9999202. So I think we can round that up to 12. So there's that. All right. So now this was the Thursday, Friday notes. Okay. So now we're moving on to the Monday/Tuesday notes. So again, the people who were in class Monday, y'all have already seen these. Again, if you weren't in class or need to go back and double check something, that's fine. The Tuesday people, the even classes, these are going to be new to you. So logarithm property number 1, change of base form. Again, I'll pause for a few seconds just so you can get this written down and then I'll move on. All right. So again, I'm going to pause for about 10 seconds real time here so you can actually pause the video, and then I will go back and talk about it. All right, the change of base formula is used to calculate the value of a logarithm that is not in base 10 or is not an easy to calculate log. Well, we just talked about base 10. When it's in base 10, we could just punch it in the calculator. Okay, I know we did a log base of 100 and came up even, but even if you're asked to do log of 73, you literally just punch in log of 73 and hit equals. Okay, or it's not an easy to calculate log. So when I say easy to calculate, I'm talking about base that is not 10, but again, it's something we can kind of do in our heads. So for example, log base 2 of 8. Again, the question is 2 to what power that goes over here is equal to 8? 2 to what power is equal to 8? 2 times 2 times 2 times 2. How many times do I got to do that to get 8? Of course, the answer is 3. 2 times 2 times 2. Log base 3 and 9. 3 to what power is 9? 3 squared. So 2. Okay. But even on those, you could actually use the change of base formula, which I'm about to show that with this one. Okay. You can still use it on those if you want to. All right, change of base formula. Again, I'll pause for about 10 seconds. Y'all pause the video and write it down, and then I'll talk about it. All right, change of base formula. Log base b of y, we're still operating with that, is equal to log of y over log of b. Down there in the red, remember, for a log with no base, we assume base 10. So again, I'd rather you try to get used to operating without having to write the 10 down there, but if you need to write the 10 down there for now, that's fine. But again, all that 10 means is, showing you that you're using the log base 10 in here, because there's other log buttons you can hit if you get the second button, or just the regular log in the calculator, because again, that log is programmed to be base 10. So we'll go through a couple problems showing this here in a second. But the one thing you can do when you do the change of base formula is to check your answer using exponential form. So here's what you got to remember, okay? Log base b of y, I'm putting it on the other side, is equal to x, okay? But I also know log base b of y is equal to log of y divided by log of b. So when I do this, this is my x. This is the x I'm looking for. So to make sure you did it right, you want to check it using exponential form. You're going to take your b, raise it to the x power, and make sure you get y. If you do b to the x power and you don't get y, you did something wrong over here. So again, I'll show that here in a second. All right, example number 1, log base 2 of 8. Again, we just said in the notes, this is equal to 3. All right. I just realized I forgot to erase that. Gosh darn it. Well, I might have already saw it, might already paused to write it down, but I'm going to erase it and we'll talk about it again. All right, so log base 2 of 8. We're converting it using the change of base formula. So it's going to be log something over log something. All right. So log of y is 8. So log of 8 over log of b, which is 2. So log of 8 over log of 2. Again, it's important that you write it like this, all right? A lot of times people get in a rush and they'll type in their calculator log of 8 divided by 2. That's incorrect. It's going to give you the wrong answer. It's got to look like log of 8 divided by log of 2, which again, I'll show in a second, because there's another place you can mess that up punching it in your calculator. All right, so punching it into your graphing calculator, scientific calculator. All right, straightforward as it can be. You want log of 8. You got to make sure you close this parenthesis right here. That's important. Divided by log of 2. That's how the display should look. Okay, we know we're supposed to get 3 from up there previously. All right. So again, let me drop out real quick so y'all can see the calculator. All right, we've got log of 8 divided by log of 2. I hit equals, that gives me 3. So I got what I was looking for. Okay. But again, let's make sure why it's important. I said make sure you close that parenthesis. Okay. So what happens if I don't do that? Oops, I deleted that. My bad. All right. Well, let me clear everything out and do it again. All right. So I got log of 8. All right, log of 8. I'm not going to close the parentheses. I'm going to do divided by log of 2. And I did close the parenthesis there. So what this is actually going to do, because of order operations, it's going to calculate whatever the log of 2 is. Then it's going to do 8 divided by that decimal and get whatever that number is. And then it's going to take the log of that. So it's not going to give me 3. It's going to give me 1.42448.025. So you gotta, that's why typing this in precisely is so important, and why I've tried to show y'all as much as I can on this video and the previous video. Again, it's hard unless y'all come to me for office hours, try to show me specifically what you're doing so I can see what you're doing right and what you're doing wrong. It's y'all aren't in class for me to check right now. So, I'm trying to show you as best I can, but if you're struggling not getting the right answers, that's when you need to come to office hours. All right, so we know we got that one, did 3. So on your phone, it's going to be different. I showed y'all already. You actually got to hit the number first and then log base 10. So when you do that, it's automatically going to pop out a decimal. I don't even have to hit equals. Okay. So let's pull up the phone again. I'm going to do 8. I'm going to hit log base 10 like I just did. Again, I don't have to hit equals. Oh, I think I hit ln. I did hit on. I know I hit on. Try it again. All right, 8. Got my finger over far enough. Log of 10. There we go. 0.903088089986991944. So you need to leave that whole decimal in, but we're going to round it to 0.903 when we write it down. All right, so I'm leaving this whole decimal in. I'm going to hold my calculator up, continue to hold it to show you that's what I'm holding up. And then again, when I did 8 log base 10, it automatically gives me 0.903. Now I'm going to hit divide again. I could have hit, this is what shows up in your display, even though your divide button on your calculator looks like this, but I'm hitting it now. Okay. So now we got to do 2 log base 10. All right. So 2 log base 10. Green is almost fading away on me. All right, so we still got it. So up here in the upper, very top of the orange column, I'm trying to get my hand out of the way, is the division. So you're gonna hit the division, okay? It's division, very top of the orange buttons. You can't even really see it. All right, so now I'm gonna hit 2 log base 10. So that is log base 10 of 2. Okay, log of 2, 0.301. So again, let me back out real quick here. So again, the 2 log base 10, it's doing 0.301. So essentially, this is what you're doing, and I'm showing it up here for a reason. 0.903 divided by 0.301. That's essentially what you're doing down here, okay? And we're going to go ahead. I'm going to go ahead and write 3 because I'm going to tell you that's what we're going to get. So I've got it up here. Now, get the screen to pop back up. I hit equals, and there's my 3. All right. So there's that. All right. So coming back here now. All right. Again, we know we were supposed to get 3. We got 3. We got 3. Okay. The one thing I'll say is this, because I was trying to do it here. If punching the long chain into your iPhone calculator is tough, do 8 log of 10, get this. Okay. Let me write it down here. Do 8 log of 10. Oh, I already had it written actually. 8 log of 10 to get 0.903. All right. Go ahead and write it in your numerator. Hit clear. Do 2 log 10 to get 0.0301. Put it in your denominator. Hit clear. And then do 0.903 divided by 0.301. You still get 3. All right. So there's my answer. And again, if you want to check it, this is now how your check has to look. Now you're going to do 2. Again, we're converting it to exponential form. All right. B to the x power equals y. So you got to ask myself, is 2 to the 3rd power, 2 cubed equal to 8? Well, again, hopefully you don't have to actually punch that in your calculator. And you should know 2 cubed is equal to 8. All right. So that one's good. Next one's going to be a little tougher. All right. Log base 5 of 115. So going into this one, log base 5, I'm saying 5 squared is what? 25. 5 cubed is what? 125. So log base 5 of 25 is 2. Log base 5 of 125 is 3. So my log base 5 of 115 is in here in the middle somewhere, and it's a lot closer to 3 than it is to 2. So I know right at the bat, I should probably be getting like 2.8, 2.9, something pretty close to 3. So we're going to transform it. Again, I don't have it written this time, but log of 115 over log of 5. Again, you'll punch that in your calculator. Got to punch in exactly as is. Make sure all your parentheses are in place. All right, and then in your phone's the same way you did previously, except instead of 8 and 2, now you're using 115 log, which will give you log base 10. Let's make sure we have that down there. 115. Not gonna blow the screen up this time, but 115. Come over here next to the 4, hit log base 10. I get 2.060697. So again, we're gonna leave the whole decimal, but we're gonna round that. I put equals. I did not mean to do that. I'm sorry. Again, you don't have to hit equals. It's automatically gonna be there. So 2.061, underlining what automatically is going to pop up. Hit divide. So I'll come upper right-hand corner, hit divide. And then I'm going to hit all the way in the middle. There's my 5 log, which is 0.68 or 6989700. So we'll do 6.99 for 3 decimal spots. So 5 log base 10, which is 0.699. Hit equals. So let's hit equals. And I get 2.948. 2.948. So let me move these up here. This is essentially what we're doing. This is even doing the same thing. And either way we get it, we get 2.948. 2.948. So down here, we left the entire decimals in. This entire decimal, this entire decimal. I didn't cut it off. Okay. Here, it automatically kind of does that. If you do it individually and cut it off, again, that's fine. So if you actually stick 2.061 divided by 0.699 in your calculator, okay? What y'all see is if we look at this, I got 2.94819. 2.94819. Just because of rounding the decimals, it's going to be slightly different. Instead of 2.94819, now I've got 2.94849. Really could round up to 2.9845. So my decimal is slightly different. In this case, it's not really going to change what my answer is, but again, just keep that in mind when we're having decimals and rounding them, that your answers might be a tick off from what you're looking for, which is really what I'm gonna highlight here in a second. All right, so we're saying this is equal to 2.948. All right, so if we do our check, we're gonna do 5 to this power. So 5 to the 2.948 power. Again, we knew the last one, 2 cubed, was equal to 8, but to do my check now, I actually want to do 5 to the 2.948 power. So again, we just got done doing some exponential functions, so I guess I'll show them both in here real quick just to be safe. So 5 caret 2.948. So there's that one. I'll hit equals just so y'all can go ahead and see it. 114.96. All right. And then over here, we're going to do, we're going to hit, no, not 4. I'm going to hit 5. Where's that X to the Y button? I believe it's right here. All right, 5 to the 2 point, this is hard, 9, 4, 8. Got it. With my pinky. Equals, same thing, 114.96. All right. So again, both ways we did it. We got 114 point. It's freezing on me a little bit here. Streaky. All right, 114.96. But again, that's because we rounded this. I mean, this is this is basically 115. So your answer is good. And again, on a test, it's not going to be 2.9. Multiple choice answers aren't going to be like 2.948, 2.949. They're not going to do that. So you're good there. All right. So for the homework, we got 4 different things you got to do for the homework. Okay. So we will go back over those right now real quick. All right. You've got 6 problems. So it's in Canvas. I'll say them again here. So you have to pull up the book PDF that I attached in the Canvas assignment, page 314, 5 through 10. Let me actually look at the books I got right here because I forget which one's which. 5 through 10 and 11 through 16. So let me look. Rewrite the equation in exponential form. All right, so 5 through 10 are like these. You have a logarithmic function, you got to rewrite it as an exponential one. This is page 314, 5 through 10. You got 6 problems that are like this, converting from log to exponential. For numbers 11 through 16, right after it, you're going the other way. You're starting with the exponential function and converting it to logarithmic function. Numbers 27 through 30 are going to be like we did right here. You got 2 common logs and 2 natural logs. Okay, a couple of them have fractions, but you're just going to put the fraction in parentheses. So just punch in log of if it's you have natural log of 1/3 on one of them, but if it was log of 1/3, log parentheses 1 divided by 3 close parentheses equals to get whatever it is. So that's 27 through 30 on page 314. And then your other 6 problems are using change of base. They're using this change of base formula. And again, you can go back over the 2 examples. And if you feel like you need to check your work, we discussed how to do that as well. And that's on page 332. I don't think I said that. So page 332, numbers 33 through 38. All right, so that's it for this video. If y'all got any questions, send me a message on Remind. Otherwise, till next time I see you in class, Coach Scharf, signing off.